properties of the elements, and chapter 7 is mostly just definitional. There's one math problem. We'll do it in this first section. Other than that, you're good. And it's just addition and subtraction. Okay, first thing we got to talk about is now that we've done electron configurations, the closed shell. So with chlorine, this would be the neon closed shell. So this is the closed shell. These are the core electrons. These are electrons in filled shells, or what we like to call the noble gas configurations. Okay, the ones outside the filled shell are called valence electrons. These are electrons in the shell that is filling. Okay, now when we look at core and valence electrons, they have different properties. Here's your core, and again, this could be replaced with your neon. The rule of thumb basically is you can mess with electrons in the filling shells. So we call these the valence electrons. You can add or subtract those at will. You start messing in the core electrons, you're talking about incredibly high energy levels. And that would be where we would start getting into some of the nuclear reactions, etc., which we're not doing at all in 1211, but that's what we get into there. So you have to look at them accordingly. Now, we said that electrons are moving charges, right? So that's Coulombs Law, basically says the potential of electron of two charged particles is a function of their charges and the distance separating them. So here is Coulomb's equation, and you look at it and go, oh, look, it's pretty. Okay, this is the part I want you to focus on. And this is basically the take-home message. We're not going to work these problems at all. For like charges, energy is positive, and the distance increases for like charges because we have repulsion. Like charges are going to repel. Okay, for opposite charges, energy is negative because the distance is going to decrease. Think of magnets, they're going to want to snap together because this is attraction. Okay? As the charges increase overall, the energy is going to increase because look at it this way. Basically, you have the charges in the numerator and the distance or the radius, which is the distance, in the denominator. So as the distance gets larger, the energy goes down. As the distance gets smaller, the energy goes up. And if the charges are the same, then it goes way up. If the charges are opposite, then it actually goes down because you have that positive negative thing going on. All right? So what actually happens because of this core valence concept is that the core electrons pull in tighter and they act as a shield. So for example, if you're trying to keep something cold, we were talking about thermodynamics, and we were talking about if you pack things in a cooler and you cover them with paper and stuff, they'll stay colder longer. Because what you're doing is by adding that paper, you're acting as an insulation. So remember, all of your positive is here in the center. So if you're surrounding it with negatives, then you're blocking some of that positive, right? So the net effect is that the valence electrons see less of the positive from the nucleus. We call this shielding, or the shielding effect. And so what that is the actual nuclear charge felt by an electron. And since you could do this for each electron, we're not going to do that. But basically the trend for shielding increases from left to right across the periodic table, and down the table the change is minimal, and that's because of the way the electrons go in. So when we're talking about these trends, we'll talk about them with respect is it's going to increase this way. And the trend here is not really. Okay. So that brings us to what is the effective nuclear charge. And this is your one math chart problem. And it's actually kind of fun because it's real simple. So what it is the effective nuclear charge is equal to the nuclear charge, which is positive, plus the core electrons, which are negative. So again, we're going to need your periodic table. So if you look at lithium, lithium has 3 protons, so it has a 3 plus charge. So the nearest closed shell is helium, which has 2 electrons. So the valence electrons are going to feel only the 1 plus. This is what they feel. So let's do a couple more. So if we look at sulfur, the nearest core to sulfur is argon, but we'll get to that one in a minute. So sulfur has the atomic number of 16, so it has 16 protons, so it's a 16 plus. And the nearest core is argon, and so your argon core has 18 electrons. Well, then that can't be right. No, it's neon. That's why you got to look at it again. So it's neon. So neon has 10 electrons. Whoops. So we don't put that in as 10 electrons. We put that in as a negative 10. So positive 16 plus negative 10 gives you plus 6. So basically the valence electrons only fill a 6 plus charge. They don't fill all 16 positives. Alright, so let's do another one. So here we go. We'll go ahead and do cobalt. Cobalt has an atomic number of 27. So that means it has 27 protons. So the nearest core to cobalt is the argon core, and the argon has 18 electrons. So that means that 17 minus 18 is, 27 minus 18. And the kind of day I'm having, I'm going to actually use a calculator because it's one of those days. Okay, so you're going to have a 9 plus charge. So the valence electrons for cobalt, which has 27 protons, is only going to fill a 9 plus. So another one is yttrium. Yttrium has an atomic number of 39. So it has 39 protons, and the nearest core to it is 36. Is krypton, which has 36 electrons. So minus 36. Do you have to put the core in? No, I'm just trying to point it out. So the valence electrons for yttrium only fill a 3 plus charge. So you will have a problem like this on the exam. And all you have to do is be able to identify how many protons it has and the core valence, the core electrons, which is the nearest closed shell, and you are good to go. Okay? Now, if you want to read a little bit more of this, other than just in the regular section of the book, you can look at the closer a look, which is the effective nuclear charge, and it walks you through how this is. So remember, effective nuclear charge is the effective. Okay, so we're done with the first section of 7.